Okay, what we're going to do is make progress on the last example. Remember the last example, we were looking at this matrix with the funky numbers. We did a lot of linear algebra to find out that one of the eigenvalues was 2, but so far we haven't actually found the eigenvectors. Now, when we did this before I turned this into a matrix equation, I just want to show you what you do if you don't like to do a matrix equation. I can just multiply the whole top out here. I would get 8x minus 2y, and that would be equal to 2x. I would get 15x minus 3y, and that would be equal to 2y. I now bring the x's over on the left-hand side, and so I would get 6x minus 2y equals 0. I would get 15x minus 5y equals 0. If someone says solve this system of linear equations in linear algebra class, the most common way to do this is just to put it in an augmented matrix, which means you put the coefficient matrix first. Remember, to augment just means to make bigger, so we made bigger by adding the zeros on the other side. We are supposed to row reduce. Well, this actually is a very simple row reduction. I'm not going to write it out, but you should be able to do it. What we're going to get is just 1 minus a third, 0, and 0, 0, 0, just like that. Remember how this works. We put the variables back in. So I'm going to write x minus 1/3 y equals 0. We solve for the leading variables. So I'm going to get x equals 1/3 y, and now y can be anything. And remember, we're looking for vector xy. Let's see here, I'm going to put the conclusion up here, right? The vector xy we're looking for would be equal to y, and remember y can be anything here, times the vector 1/3 1. And so we can pick any y we want. I'm going to choose y equals 3, and we're going to get an eigenvector of 1, 3, which I believe is the eigenvector we showed. Now, recapping just what went on here. Previously, we found out that one of the eigenvalues was 2. What does that mean? That means when you plug the vector xy into this linear transformation, that specific vector just gets doubled. We rewrote this matrix equation, in this case, as a system of linear equations. We solve systems of linear equations by getting all the constants on one side and all the variables on the other. We put it into an augmented matrix. We row reduced, echelon formed it, and then we solved the way we're supposed to. What we found out, by the way, is that there's an infinite number of eigenvectors, but they're all multiples of one basic one. The basic one I chose was when y equals 3, so I get nice numbers, and I picked 1, 3. What I would like you to do for the next activity is to find the eigenvectors when the eigenvalue is 3.